Welcome to the second video of Lesson 2, where we will conduct another probability experiment. This one involves rolling a die. If you happen to have your own die, you can certainly conduct this experiment on your own and compare your results with those obtained in this video. Consider rolling a fair die 30 times. How many times would you expect to get a 1, 2, 3, 4, 5, or 6? When we are talking about what we expect to get, we are referring to the theoretical probabilities. We have already discussed that if we roll a die once, the probability of obtaining each of these values would be 1 out of 6. If we roll a die 30 times, I'm going to write an equivalent fraction for 1 over 6 with a denominator of 30. That will give me 5 over 30. What that means is that we would expect to roll each number 5 times in 30 trials. In other words, the probability of obtaining a 1, 5 out of 30, a 2, 5 out of 30, and the same holds true for the 3, 4, 5, and 6. We would expect to get 5 1s in 30 trials, 5 3s in 30 trials, 5 6s in 30 trials. Those are the theoretical probabilities. To obtain experimental probabilities, let's do this. We have our table where we will tally our experimental results and then figure out the experimental probabilities to then compare them with the theoretical probabilities. Will we get 5 1s, 5 2s, 5 3s, and so on? That's what we're going to find out. I'm going to roll my die, and let's see what happens. 3, a 2, a 1, another 3, another 3, another 3, a 5, a 1, a 6, another 1, another 1, another 1, a 5, a 2, another 1. We are halfway there. That's 15 trials done, 15 more to go. 6, 5, another 1, 4, that's our first 4, another 1, 6, a 2, 5, another 2, a 4, one. That leaves us with 4 more rolls. Another 1, 5, 2, and our last roll, we get another 1. Okay, 30 rolls of the die complete. Let's put in our experimental probabilities. For 1, 11 out of 30. We rolled 11 1s in 30 trials. 2, 5 out of 30. 3, 4 out of 30. 4, 2 out of 30. 5, 5 out of 30. And 6, 3 out of 30. Normally, to express final answers, we would put these in simplest form wherever possible. In comparing here, though, I'm going to leave them as denominators of 30 to make it a lot easier. Observations, we notice that in the case of rolling 1, our experimental probability was significantly greater than the theoretical. In rolling a 2, our experimental and theoretical probabilities are the same. In rolling a 3, they're pretty close. In rolling the 4, well, experimentally we rolled 2, which is a bit less than the theoretical roll of 5. For rolling a 5, our experimental and theoretical probabilities are the same. And for the 6, our experimental probability was slightly less than the theoretical. I do want to reiterate an important point here. Just because your experimental probabilities don't equal the theoretical, that doesn't mean you did anything wrong. It is what it is. You can only record what the die actually rolled. It's just interesting to compare the values. If we do a little post-experiment discussion now, some findings or conclusions. Obviously, theoretical and experimental probabilities do not have to be equal. What we expect to happen and what actually happens are often different. However, and this is an important point, it is true that as more trials, or sometimes we call them iterations, are carried out in an experiment, the experimental probability will become closer to the theoretical probability. That is a proven fact. At this point, you can either go ahead and conduct your own experiment with the die, or you can proceed to the activities for Lesson 2.